Okay, so this is a key to test 4. Number 1, it says assume that all variables represent positive real numbers. So really that means that you don't have to worry about any of these absolute values like we did in a previous lesson. Okay, so in part A, you have the square root of 45, x to the 6, y to the 7. Now remember, we're only dealing with square roots here. And so remember we did, in terms of the variables, the easy kind is where the exponent's even. Okay, the index is even because that's a 2, and the exponent's even. All right, and remember, basically we just said 6 divided by 2 is 3. Okay, now right here, this exponent's odd, so we have to rewrite it. And then 45 is not a perfect square, so we have to ask ourselves, what perfect square was the largest perfect square that goes into 45? And so the answer is 9. So what we did was we wrote this as the square root of 9 times 5 times x to the 6. So you leave x to the 6 as x to the 6 because the index is, the exponent is even. Now, y to the 7, since that's odd, remember my index is even, so since that's odd, we're looking for the largest even number that's less than 7, so it will be y to the 6. So we're going to rewrite y to the 7th as y to the 6, y to the 6 times y. Okay, and y to the 6 times y is still y to the 7. All right, now I'm going to circle the ones that I can simplify. Right, so the next step is to simplify each part as you can. So I'm going to circle the ones I can simplify. I can simplify the square root of 9. I can simplify the square root of x to the 6. I can simplify the square root of y to the 6. And so I would get the square root of 9 is 3. The square root of x to the 6 is x cubed, because remember what we did, we said 6 divided by the index 2, which is 3. And then same thing for y to the 6, so it's y cubed. And then you're left with the square root of 5y. And so that's the answer. So 3x cubed, y cubed, square root of 5y. Okay, the next one, you have the square root. I'm just going to go ahead and rewrite it to make it a little bit bigger. You have the square root of 81x y to the 10th. All right, and then right away you notice that 81 is a perfect square. Y to the 10th is even. Now x to the first, that one's odd, but it's less than the index. See here, that 7 was bigger than the index, so you can rewrite it. So I can't rewrite this, and so the x rather, and so I can simplify this. I can simplify this, and that's about it. And so I get the square root of 81 is 9. The square root of y to the 10th, 10 divided by 2 is 5, times the square root of x. So the answer is 9y to the 5th, square root of x. Over here, all of these I can simplify because the exponents on these are both even. The square root of 100, 100 is perfect square, so the square root of 100 is 10. So I get 10 x to the 4th, y to the 7th. So 10 x to the 4th, y to the 7th. Okay, now over here, again, you're simplifying, but you got to remember that the square root of negative 12 is really negative 1 times, and I'm going to rewrite 12. What perfect square goes into 12? Well, it's going to be 4, so I'm going to rewrite this as 4 times 3. Okay, so negative 1 times 4 times 3 is a negative 12. And we have to remember this. We have to remember that the square root of a negative 1 is the imaginary unit, which is just I. Okay, so this right here I can simplify. This right here I can simplify. So I get 5 times I, square root of negative 1 is I, square root of 4 is 2, and I'm left with the square root of 3. And so then that becomes 5 times 2 is 10, so it becomes 10I square root of 3. Over here, square root of 75. What perfect square goes into 75? Let's pick the largest, and the answer would be 25. So that's 25 times 3. And I can simplify the square root of 25, so that's 5 square root of 3. Okay. Number 3. Okay, so we need to use the quadratic, solve each quadratic equation, use the quadratic formula. And remember, we got to put in standard form. Remember, the quadratic formula is if the variable is x, you'd say x equals the opposite of b, plus or minus the square root of b squared, minus 4ac, all over 2a. Notice, all over 2a. Not this, but all of this over 2a. Okay, now, it helps if we determine what a, b, and c are. So a is a coefficient of x squared. That's 6. B is a coefficient of x. Now remember, the coefficient of x here is a negative 1. You got to keep the sign. It's a negative 1, not 1, a negative 1. And c is your constant. My constant is not 15. My constant is a negative 15. Because remember, in a previous course, you wrote this right here, if you want to think about it, you wrote this as 6x squared. Remember, subtract x means add the opposite. Subtract negative 15 means add the opposite. Okay? So this is a negative 1, this is a negative 15. So c is a negative 15. So it's very important. We've talked about this multiple times that you got to keep the signs correct. Otherwise, if A, B, and C are incorrect, you're actually solving a different quadratic equation than what this is. And now all you do is just plug these values back into the formula, and so you have this. You have x equal. All right, this says the opposite of b. Well, b is a negative 1. The opposite of a negative 1 is 1. Plus or minus the square root of b. B is negative 1. Put that in parentheses. Squared. Minus 4 times a. A is 6. Times c, which is negative 15. All over 2 times a, which is 6. Okay, let's simplify the discriminant. Let's simplify the radicand. 1 plus or minus the square root of. Now remember, if b is not 0, if b is any other number than 0, remember when I square b, it should always be positive. So this part right here should never be negative right here. The b squared should never be negative. So negative 1 times itself is a positive 1. All right, and remember, a negative subtracting 4 means add the opposite. So this you can think of this as negative 4. A negative times a positive times a negative is a positive. You learned that in another course. All right, now let's figure out what 4 times 6 times 15 is. So 4 times 6 is 24. 24 times 15 is 360. All over 12. And now 1 plus 360 is square root of 361, all over 12. Now, when we get to that point, you want to ask yourself, is 361 a perfect square? Well, take the square root of 361 and see what you get. So when I take the square root of 361 in the calculator, square root, 361, I take the square root, I get 19. So 361 is a perfect square. So when I take the square root of 361, I get this. I get 1 plus or minus 19 over 2, which means that this, since there's no square root left, that means that this will be rational solutions. So since there's no square root in my answer, I'm going to rewrite it as 2 separate rational solutions. So I'm going to say 1 plus 19 divided by 2, 1 minus 19 divided by 2. 1 plus 19 is 20, so I get 20 divided by 2. 1 minus 19 is negative 18, so negative 18 divided by 2. So I get 10 and a negative 9. All right, so let me make sure real quick I didn't do anything wrong here. So opposite of b, 2 times 6 is 12. Oops, I did. Okay, so I said 2, right? That's 12. So always be careful. 12, 12, 12, 12, 12, and that's going to change this. So 20 divided by 12 reduced is, they're both divisible by 4. So 20 divided by 4 is 5. 12 divided by 4 is 3. Here, these two are both divisible by 6, so that's negative 3 halves. So the answer is x equal 5/3, comma, negative 3 halves. All right. Okay, the next one, again, it's also in standard form. In this case, A is 1, B is 8, C is negative 16. And so you just plug these back into the formula. So x equal. So this says, remember, the opposite of b. So the opposite of b here, if b is 8, the opposite of 8 is a negative 8. Plus or minus the square root of b squared. So that's 8 squared. Minus 4 times a times c. All over 2 times a. And so a is 1. So I get negative 8 plus or minus the square root of 8 squared is 64. 4. A negative times a positive times a negative is a positive. 4 times 1 times 16, if you use your calculator, that's 64 as well, divided by 2. So I get negative 8 plus or minus the square root of 128 divided by 2. Now, if you take the square root of 128, you're going to notice that it's not a perfect square. You're not going to get an integer. So you got to figure out what perfect square goes into 128. Well, just look at this. So see the 64 plus 64? 64 plus 64 really means 2 times 64. And 64 is a perfect square. So basically 64 is the largest perfect square that goes into 128. And so I get negative 8 plus or minus the square root of 64 times 2 over 2. And the square root of 64 is 8. So I get negative 8 plus or minus 8 square root of 2 over 2. And notice, see how you have a square root in the answer? So that's an irrational. So these are irrational solutions. So the way you want to write it is this compact form. So with rational solutions, you split it up and you wrote as 2 separate rational solutions. Here, just keep in mind though, see how these 3 numbers right here are all divisible by 2? So this really is negative 8 over 2 plus or minus 8 over 2 square root of 2. So that's negative 4 plus or minus 4 square root of 2. So that goes here. So 4 plus or minus 4 square root of 2. Or you could rewrite it as 4 plus 4 square root of 2, comma, 4 minus 4 square root of 2. Right, so either one's fine. All right, C, going 4. So 4, you wanted to solve each of these quadratic equations by using a square root property. And so remember, when using a square root property, you have to have it's got to be this form here where you have an algebraic expression squared equal a number. All right, and so here that's not the case. You have x squared plus 20 equals 0. So what you have to do is bring 20 over, so you have to subtract 20 from both parts first, from both sides. So I get x squared equal to negative 20. And now this looks like this. And so now we can take the square root of both sides. And remember, when you take the square root, you're going to have that plus or minus. And we had the discussion in previous lessons as to why we need this. And so the square and the square root undo each other. So you get x equal plus or minus the square root of a negative 20. And then if I figure out the square root of a negative 20 is, so remember that's the imaginary unit is going to be involved here. So that's the square root of a negative 1. The perfect square that goes into 20 is 4, so that's 4 times 5. The square root of a negative 1 is I. The square root of 4 is 2. And I'm left with the square root of 5. So that's 2I square root of 5. And so that becomes plus or minus 2I square root of 5. Okay, the next one, see that is already in this form right here. So I'm going to go ahead and rewrite this. Okay, now I'm going to take the square root of both sides. So remember, right now I'm squaring x plus 3. The opposite of squaring is to take the square root. Both sides. Don't forget the plus or minus. So the square and the square root undo each other here. So you get x plus 3 equal. Now this becomes plus or minus. Remember, square root of negative 36 is the square root of a negative 1 times 36, because 36 is a perfect square. And so square root of negative 1 is I. Square root of 36 is 6, so that's 6I. And so this right here becomes plus or minus 6I. So now I'm left with complex solutions. So you got to get x by itself though. So you can subtract 3 from both parts just like this. And so combined like terms, 3 and a negative 3 is 0. So you're left with x equal. All right, and this becomes negative 3 plus or minus 6I. Negative 3 plus or minus 6I. So that's your answer. Negative 3 plus or minus 6I. Or if you wanted to rewrite it as separate solutions, you'd say negative 3 plus 6I, comma, negative 3 minus 6I. Okay, the next one, you wanted to solve this by factoring. All right, so let's first of all put this in standard form. So that's 6x squared plus 7x minus 3 equals 0. And so I'm going to go ahead and factor this. And let's try 3x, 2x. Let's try 3 and 1. And Remember, the last sign's negative, so these signs have to be different. And the outer and the inner, the larger of those, will take the middle sign. So let's see, this is 9x, this is 2x. So the 9x has to be positive, and the 2x has to be negative. And always check yourself, make sure you get this back. 3x times 2x is 6x squared. A negative 1 times a positive 3 is a negative 3. 3x times a positive 3 is a 9x. A negative 1 times 2x is a negative 2x, and when I add them up, I get 7x. And now I set each factor equal to 0, because we're solving this by factoring. This is an equation. So I get 3x minus 1 equals 0, 2x plus 3 equals 0. And then I just solve each linear equation. So 3x equals 1, x is 1/3. Here I get 2x equals negative 3, x is negative 3 halves. So x equals 1/3, comma, negative 3 halves. Okay, now, number 6, you're adding and subtracting rational expressions. Okay, so first of all, remember you got to factor your denominators to find the LCD. So this right here, that's the difference of two squares. So that's x minus 4, x plus 4. And so the LCD then would be, your first factor is x minus 4. I have 1 here, I have 1 here, so I need 1. My next factor is x plus 4. I have 1 here, none here, so I need 1. So this is your LCD. Your LCD is x minus 4 times x plus 4. And now you're going to write two fractions, two equivalent fractions with that LCD. X minus 4, x plus 4, x minus 4, x plus 4. All right, now, so you want to figure out 7 divided by x minus 4 times x plus 4 is equivalent to what with that denominator? 2 divided by x minus 4 is equivalent to what with this denominator? So you gotta figure out what's missing. Okay, so this denominator right here I already have, so nothing's missing. So this denominator is the same as this, which means the numerators have to be the same. Basically, you're saying times 1 times 1. And so you get 1 times 7 is 7. Over here, though, I have an x minus 4, so I already have this part. I'm missing the x plus 4. So you got to say times x plus 4 times x plus 4. So what I do to the denominator, I got to do to the numerator. So basically what you have right here is 2 times x plus 4. All right, now distributing here, I'm going to get 7 over x minus 4, x plus 4, minus, and then that becomes 2x plus 8 divided by x minus 4, x plus 4. Remember, always leave the denominators factored. Now write this as one fraction, so I'm going to get x minus 4, x plus 4, and my numerator then becomes 7 minus, now remember you're subtracting, so put that in parentheses, so you're subtracting 2x plus 8, which really becomes 7. Now to get rid of the parentheses, you're going to distribute the negative through here, so that's minus 2x minus 8 over x minus 4, x plus 4. And so 7 minus 8 is a negative 1, so I get negative 2x minus 1 divided by x minus 4, x plus 4. All right, so that's your answer. So 2x minus 1, negative 2x minus 1 divided by x plus 4, x minus 4. Okay, now the next one. All right, so factor the denominators. I get, let's see, that'll be x minus 2, x plus 1. Over here, when you factor out a 3, that's 3 times x plus 1. So the LCD here for this one will be the monomial factor 3 times x minus 2, x plus 1. X minus 2, x plus 1. So that's your LCD. So I'm going to write two fractions with that denominator. All right, so two fractions with that denominator. All right, now this is what I had, this is what I need. So if you look at this, what's missing in this is 3. So I'm going to multiply this by 3, but what I do to the denominator, I'm going to have to do to the numerator. So put that in parentheses because all this has to be multiplied by this 3. Over here, I have 3 times x plus 1. So I have the 3, I have the x plus 1, but I'm missing the x minus 2. I don't see it. So I got to say times x minus 2, but what I do to the denominator, I do to the numerator, x minus 2. All right, so basically in this numerator right here, I have 3 times x minus 3. In this numerator over here, I have 3 times x minus 2. That's what I have. Okay, now let's get rid of the parentheses in the numerator, so I'm going to use the distributive property. Leave the denominator factored. So I get 3x minus 9 over here, divided by the denominator, the LCD, minus, and over here that's 3x minus 6. All right, now I'm going to subtract. I'm going to write this as one fraction now. So what I'm going to get is 3x minus 9. And be careful, you're subtracting, so you got to be careful when you subtract. This is adding will be easy, but you're subtracting. So I'm subtracting this numerator, so put that in parentheses. Now get rid of the parentheses. I'm going to get 3x minus 9 minus 3x, so just distribute the negative 1, so minus 3x plus 6 divided by the denominator. And so I'm going to get 3x minus 3x is 0, a negative 9, and a positive 6 is a negative 3, divided by the denominator. And then I notice that this negative 3 and this 3 can reduce, so that's going to be 1, that's going to be negative 1. And so the answer becomes negative 1 divided by x minus 2 times x plus 1. That's your answer. Okay, 7. Now you're dealing with complex fractions. So the LCD in the first one, see where you have your denominators are 3, 3x, x, and 3. Again, you still want to factor if you can, but these are all monomials, so I can't do anything with those. So the denominator will be, the LCD then will just be 3x. That's your LCD. So 3, 3x, x, and 3. All right, so every factor you see has to be in the LCD. So I see a 3, there's a 3. I see a 3x, there's a 3x. I see an x, there's an x. I see a 3, there's a 3. Now what you do now is you take the numerator part of this complex fraction and you multiply by 3x. You take the denominator part of the complex fraction and you multiply by 3x. And now you're going to distribute. You're going to distribute. So you can say 1/3 times 3x plus 1 over 3x times 3x. So you took each fraction and you multiplied by 3x. Divided by this fraction, 1 over x times 3x, plus this fraction, 1/3 times 3x. Okay? Alright, so let me go ahead and rewrite this quickly. I'm just rewriting what we just wrote. And, alright, so now we're going to reduce. So remember, the whole purpose of multiplying by the LCD, the numerator and denominator by the LCD, is to clear these fractions, is to clear all these fractions right here, the 3, the 3x, the x, and the 3. And we can now. 3 into 3 is 1, 3 into 3 is 1. 3x and 3x is 1, 3x and 3x is 1. X and x is 1, x and x is 1. 3 into 3 is 1, 3 into 3 is 1. So notice all you're left with are 1s now. And so now what you get is this. You get 1 times x is x plus 1 times 1 is 1. So there's your numerator. The denominator, 1 times 3 is 3 plus 1 times x is x. So this is your answer. You can say x plus 1 over 3 plus x, or you can say x plus 1 over x plus 3. X plus 1 divided by x plus 3. Alright, over here, you may want to rewrite these as such. X over 1 plus 3 over x divided by 1 over 1 plus 2 over x squared. So you may want to write it like those. Alright, so the LCD here of 1x, 1 and x squared is going to be x squared. So just like we did before, you're going to take the numerator part, multiply by x squared, take the denominator part, multiply by x squared, and then you're going to distribute. So you have x over 1 times x squared, plus each fraction times x squared, plus 3 over x times x squared divided by 1 over 1 times x squared plus 2 over x squared times x squared. Okay? All right, now what we have is this. We have x times x squared is x cubed plus, all right, 3 over x times x squared. So what happens is that this, remember the whole purpose of multiplying by the LCD is to clear these fractions. Okay? And so you need ones in these, you need ones here. So what I had circled in purple, you're going to need ones. So x and x is 1, x and x squared, you're left with just 1x. Okay, so that's so the numerator is going to be x cubed plus 3x divided by 1 times x squared is x squared. Over here, the x squareds divide out, and you're left with plus 2. And if you took out an x from the numerator, it's not going to help you because nothing can reduce. But you would, if you took out an x, you would have x times x squared plus 3 divided by x squared plus 2, and so that's your answer. So either one of these would be fine. Okay, number 8. All right, so number 8, you're solving a rational equation. So again, you want to state the restrictions also. Well, just as before, you got to factor your denominators. So this denominator is a y. This is a y plus 4. This one I factor is going to be y times y plus 4. All right, now before we find the LCD, let's talk about what can't y be. Well, look at all your factors. Well, this factor's a y, and you set them equal to 0. So when I set this factor equal to 0, I already have what y equals. Well, y is 0. That means that 0, when I plug in 0, 0 is in the denominator, and I can't have 0 in the denominator. That's undefined, so y cannot equal 0. So that's one of my restrictions. The next factor I see is a y plus 4. So I got to ask myself, where is y plus 4 equal to 0? Well, y plus 4 is equal to 0 when y equals a negative 4. So when I plug in negative 4 into y, negative 4 plus 4 is 0. So that's another restriction. Y cannot be negative 4. This factor is a y, I already took care of it. This factor is a y plus 4, I already took care of it. So these are the only two restrictions. Now I got to find the LCD. So the LCD, remember, of y plus 4, y plus 4 is just y plus 4. All right, now since this is an equation, the best way to do this is to multiply both sides by the LCD. So I'm going to rewrite this equation. So I have 2 over y minus 6 over y plus 4 equal 24 over y times y plus 4. So I'm going to go ahead and rewrite it using the factored part. Now I'm going to multiply this side by the LCD, y times y plus 4. And I'm going to multiply this side by the LCD. Okay? All right, now I'm going to get rid of these brackets. I'm going to distribute. So you're saying the LCD times the first fraction, 2 over y, minus the LCD times the second fraction, 6 over y plus 4, equal. And over here, I'm just going to go ahead and reduce these, and you're just left with 24. Okay, now reducing these right here, this y into this y, divide out, you're left with 2 times y plus 4. 2 times y plus 4. Minus. Over here, the y plus 4's divide out, and you're left with y times 6, which is 6y, equal 24. Distributing here, I get 2y plus 8 minus 6y equal 24. And so 2y and a negative 6y is a negative 4y plus 8 equal 24. So now I have this linear equation, so let's go ahead and solve for y. So I'm going to subtract 8, and so I get negative 4y equal 16. Dividing, okay, so remember I'm trying to get y by itself. Right now I'm multiplying by negative 4. The opposite of multiplying by negative 4 is to divide by negative 4. And so negative 4 divided by negative 4 is 1. 1 times y is y, so I get y to be negative 4. Okay, now notice that that was one of the restrictions. So remember, I can't use -4 because -4 makes that denominator 0. Now, what you found, though, was that y equal -4 is a solution to this linear equation right here. But it's not a solution to this rational equation because it makes the denominator 0. So what this means is that y equal -4, remember, that's called an extraneous root or solution. So what means that's false solution. All right, now don't ever put the word false solution here. So if that was the only number that you got and it's a restriction, it doesn't work, then you just say no solution. Don't ever write the phrase no false solution here. Don't say false solution. We what we mean when we say false solution is that this right here, y equal -4, is an extraneous root or an extraneous solution or a false solution because it satisfied this one, but it didn't satisfy the original. So we just say, since that's the only one that we got and it was a restriction, we say no solution. All right. Number 9 is where you started performing the operations on rational expressions. So here you're dividing two rational expressions. So let's go ahead and change this to a multiplication problem first. So that's 6x divided by x squared minus 1 times the reciprocal, so that's x squared minus x minus 2 divided by 2x minus 4. And so I get 6x divided by, all right, so x squared minus 1 is the difference of two squares, so that's x minus 1 times x plus 1 times over here, that's going to be x minus 2, x plus 1. The denominator I can factor out at 2, so that's 2 times x minus 2. All right, and then you start reducing. Okay, now, see this factor of 6? I can reduce to this factor of 2. So 2 into 2 is 1, 2 into 6 is 3. The x minus 2's here will divide out. The x plus 1's here will divide out. And it looks like the only thing you have left in the numerator will be 3x times 1 is 3x divided by x minus 1 times 1 times 1 times 1, so that's x minus 1. So that's your answer. So 3x divided by x minus 1. All right, over here in part B, you're going to factor. Well, the numerator here is a monomial, so just leave it alone for right now. The denominator I can factor as x plus 4 times x plus 3. The numerator up here I can factor as x minus 5 times x plus 4 divided by 10x cubed. Okay, so now let's reduce. This factor of 5 I can reduce with this 10. So that's going to be a 1, that's going to be a 2. There are 5 factors of x up here, 3 down here. So I can factor all of these with 3 of these, and you're left with 2. The x minus 5, I don't see any down here. The x plus 4, I can reduce with that one. And so you're going to get 1 times x squared times x minus 5 times 1, which is just x squared times x minus 5, divided by 1 times x plus 3 times 2 times 1, so that's 2 times x plus 3. That's the answer there. So x squared times x minus 5 divided by 2 times x plus 3. All right. Number 10, you wanted to find this function value. So if you want to find what f of negative 2 is, where we see the variable x, you plug in negative 2. So f of negative 2 would become negative 3 times negative 2 squared plus 2 times negative 2 minus 1. So where we saw the variable x, you plugged in negative 2. Now let's use the order of operations. Negative 2 squared is 4. So I get negative 3 times 4. I'll go over here. 2 times negative 2 is a negative 4. And then minus 1. Negative 3 times negative 3 times 4 is negative 12. Minus 4 minus 1. Negative 12 minus 4 is a negative 16. And a negative 16 minus 1 is a negative 17. Okay, so at number 11, you just wanted to simplify each rational expression. So basically, you're just going to reduce and divide out your common factors. So here I can factor out an x, and I'm left with 2x plus 5. Over here, when I factor this denominator, I get 2x, x, 5, 3, and the last sign's negative, so these signs are different. And the larger of the outer inner will take the middle sign, we'll take the negative sign. So it looks like this is negative, this is positive. And now if I rewrite it over real quick, I can reduce. You can see that there's a common factor of 2x plus 5. And then all you're left with is x divided by x minus 3. Okay, this one, I can factor the numerator. That's going to be x plus 3, x minus 2. The denominator, I can factor out a 3 first. So that's 3 times x squared minus 9. And then notice that x squared minus 9 is a difference of 2 squares. So I can factor the difference of 2 squares as 3 times x minus 3, x plus 3. And then reduce. These x plus 3's divide out. And you get x minus 2 divided by 3 times x minus 3. All right. And then finally, the last page is where you just had some factoring problems. So in part A, you notice that these have 4 terms, so you're going to factor by grouping. So let's group the first 2 and the last 2. And so in the first group, I can factor out an x squared, and I'm left with x plus 7. In the second group, I can factor out a negative 9, and again, I'm left with x minus 7. Always check yourself. A negative 9 times x is negative 9x. A negative 9 times a negative 7, x plus 7, sorry. A negative 9 times a positive 7 is a negative 43. And notice these two are the same. So I can factor the x plus 7 out, and I'll get x squared minus 9. Now remember, you got to factor completely, so this is not your final answer, because you should notice that x squared minus 9 is the difference of 2 squares. So I'm going to get x plus 7 times x plus 3 times x minus 3. All right, so always factor completely. Okay, over here, the first thing I can do is factor out a 3. So let's factor out a 3. So you get 3 times x squared plus 2x minus 8. And then let's factor x squared plus 2x minus 8. I get, let's see, that's going to be xx, 4 and 2, plus and minus. And so there's your answer. So it will be 3 times x plus 4 times x minus 2. Go over here. The GCF is 1, so let's go directly to the 2 binomials. So 3x, x. Let's try 4 and 3. So I know that 3 can't go here because I could factor out a 3. So let's put the 3 here, the 4 there, and see if that works. The last sign's negative. These signs in here are different. The outer is 9x, the inner is 4x, and when I do subtract, I do get 5, which is what I need. But I want a negative 5, so that means this is negative, this is positive. And always check yourself. 3x times x is 3x squared. A positive 4 times a negative 3 is a negative 12. The outer is a negative 9x, the inner is a positive 4x. When I add them up, I get negative 5x. So that's your answer. So 3x plus 4 times x minus 3. Over here, that looks like this is a sum of 2 cubes. The sum of 2 cubes. So when I cube 4x, I'm going to get 64x cubed. When I cube 5, I'm going to get 125. So again, so there's your first, there's your last. So this becomes, where your formula says f plus L times f squared minus fl plus L squared. So that's going to be 4x plus 5 times, okay, now f squared. So 4x times 4x is 16x squared. So that goes here. And then it says I take the 4x, I take the 5 and multiply them together. So it'll be minus, so it'll be 20x. And then L squared means 5 times 5, so that's 25. And so there's your answer. So you get 4x plus 5 times 16x squared minus 20x plus 25. Okay, so that takes care of the key to test 4.